This is the second lesson of Unit 7 Geometry. And today's lesson is going to be about angle properties. So angle properties are just essentially when you're given a diagram and you have to find some unknown angles, then you can use these angle properties to help you. Okay, the first set of angle properties will be when you have two parallel lines. Okay, two parallel lines like this. Okay, and they're usually indicated with a arrow. Okay, so these two are parallel, for example, or these two are parallel. Okay, and you have a line cutting through those parallel lines, which is called a transversal line. I labeled it here, transversal line cutting through the two parallel lines, and two parallel lines are always marked with a arrowhead. Okay, the first rule of angle properties is that when you have two parallel lines, a transversal line, angle A and B here will be the same. Okay, they will be congruent, and they're called corresponding angles. So angle A will be right under the parallel line, and angle B will also be under the parallel line, but it's under the second parallel line. Okay, so the first angle is going to be under the first parallel line, and the second angle will be under the second parallel line. Okay, and they meet along the same transversal line. So when you see a diagram similar to this, then angle A and B would be the same. Okay, and it's often referred to as a F pattern because the pattern forms an F shape. As you can see, I've already labeled it there. They form an F shape. Okay, they form an F shape, and these two are enclosed within that F shape. Okay. And this has another variation where this is A and this is B, and they're also the same, but this time instead of two of them being under the parallel lines and meeting at the transversal, they again meet at the transversal, but this time both of them are above the parallel lines respectively. So this is the first parallel line, this is the second one. So A will be above the parallel line and intersecting with the transversal line, and the angle B would also be above the second parallel line, and it will be intersecting with the transversal line. Hence A and B will be the same. All right, they're called corresponding angles. So our second angle property would be alternating angles, and it's often called Z pattern. So you have a transversal line here, and you have two parallel lines here, and essentially what happens is that this is angle A, this is angle B. This angle A, where it's under the first parallel line, it's going to be the same as the angle B, which is on the opposite side of the transversal line, and it also is above the second parallel line. Okay, so it's gonna look like a Z shape like that. So the explanation in words might be a bit confusing, but the diagrams itself make lots of sense. So this is the Z pattern, right? So these two angles are always the same, or these two angles, they're the same thing. So boom, 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 they're the same thing. Okay, so when you see Z pattern, you can say that A equals B. All right. So this stems from the original C pattern, F pattern, right? This stems from that pattern because you can see that this A equals this A. This is A as well, right? They're the same angle. And B and A are the same because they're opposites from each other. We'll learn that later. in this lesson. Okay, so just remember the Z pattern. One is going to be on the one is going to be under the parallel line on one side of the transversal, and another angle will be on the other side of the transversal and above the second parallel line. Okay. All right. Our third property, which adds on to this property, that's enough for these two are like the most important rules for parallel lines. You gotta remember. But then these are just complementary rules, 3 and 4. Okay. So as I said earlier, B and A are the same because they're opposite angles. So that this theorem states that A and B are the same because they're opposite from each other when two of the lines intersect. Okay. All right. Our fourth angle property is that when two angles are on the same straight line, then they add up to 180, as you see on this in that mathematical expression right there. So A plus B equals 180 because they're on the same straight line. Okay. Our fifth rule would be that when you have a right angle and in that right angle you have two angles, those two angles will add up to 90 degrees. Okay, they will add up to 90 degrees, not 180. That was a misclick. But these two angles will add to 90. Let's say you have another angle. Let's see that. That's called a C. So that will become A plus B plus C equals 90. Okay, so the whole sum of all the angles that are enclosed within that 90 degree angle, they will add up to 90 degrees. Okay. So those are like the main angle theorems. This is an example that I already did for you guys. So you're given this diagram. This is the whole, you're given that diagram, right? And you're asked to find angles Z, X, and Y. So these are two parallel lines, of course. Boom, boom. Okay. So first thing you gotta spot is that this is an F pattern. Okay, Z and 58 are part of this the F pattern, hence Z equals 58. Okay, and the next thing you guys should spot is that angles Z and X are within the same, on the same straight line. So Z and X, the sum of Z and X equals to 180. So you can subtract 58. You can subtract X. You can subtract Z from 180 to get the angle X, and X equals 122. All right. Once you have X, our next theorem we're gonna look at is that X and Y are opposite to each other, right? Hence X equals Y, so Y will also be 122. Okay. All right. So we'll move on to angle properties. So as you can see, I'm pretty sure you guys have learned this in elementary school. So we have a triangle and all the interior angles ABC add up to 180. And these two are probably new to you. Okay, so in a quadrilateral, all in a square, parallelogram, rhombus, or a rectangle, opposite sides are always congruent. Okay, so let's say A and B are opposite, right? And this is a parallelogram. A and B are opposite to each other, hence they're the same. Okay, and C and D are also opposite, so they're the same. All right, so that applies to a square, parallelogram, rhombus, and rectangle. All right, and our last rule for shape properties and angle shape properties will be that all interior angles in a quadrilateral add up to 360. Okay, A, B, C, D add up to 360. Okay, so let's see an example here. We have this quadrilateral, which has interiors Y, 120, 75, and 130. And you want to find Y, right? So we can apply the theorem here. Number 3, all interior angles in a quadrilateral add up to 360. So you can say that 120 plus 75 plus 130 plus Y equals 360 degrees. And then you can solve for Y by subtracting all these known values from 360, which gets you Y equals 35. Okay, let's do some practice. Okay, our first question, you're asked to find X and Y. Okay, First step, you can notice that these hatch marks, okay, which means that these two are parallel, these two are parallel, okay, and that means it's a parallelogram, because a parallelogram has opposite sides that are parallel, right? Two pairs of opposite sides that are parallel. Okay, so this is a parallelogram. So as you guys can remember from a rule number 2 here, that opposite angles in a parallelogram, square, rhombus, or rectangle, they will be congruent. Okay, so y is opposite to 64 in this parallelogram. So y was 64 degrees, and we have 64 here. Okay. And x, we don't know x. However, we know that this is also x because opposite angles in a quadrilateral, like a square, rhombus, or parallelogram, etc. As I said earlier from rule number 2, they will be congruent. So you can call this and this the same angle. Okay, and we know that from rule number 3 that all of the sides, interior angles in a quadrilateral add up to 360. So you can say that 64 plus 64 plus x equals 360. Okay, and you can group these two. X plus x is 2x, and then you can say 64 plus 64 would be 128 plus 2x equals 360. You can isolate for 2x by moving this over here. So that gets you 232 equals 2x, and then x would be 116 degrees. Okay, so y equals 64 and x equals 116. Alright, okay, so our next problem, we have this triangle diagram here, and you're asked to find angle y. Okay, so we first have to consider, because we can't really directly solve for y here, right? So we will consider triangle CEF first. We see that these two hatch marks here indicate that that this triangle is an isosceles triangle, which means that these two angles are the same. Okay, these two angles that are enclosed within the base and the two legs, they're going to be congruent to each other. So angle E and angle F will be congruent. Okay, and we know that the rule earlier that all the interior angles in a triangle add to 180. So we can say these two are x because they're the same angle, right? So we can call both of them x, and all the interior angles in a triangle add to 180. So we can say that 2x plus 40 equals 180. Okay. And then we can solve for x by moving this over here. So x equals 70 degrees. Okay. So we got these two angles at 70 degrees. Okay. So when we move back to the rule that I said earlier, the rule number 4 here, the rule states that all angles on the straight line will add up to 180. So, which means that this angle and this angle, we call this angle Z. So this angle and 70 add up to 180. So we can set up another equation. Z plus 70 equals 180. Z would be 110. Okay, so this angle will be 110. And to solve for y, I'm pretty sure you guys should probably see it by now. We just consider triangle CED there. So we can say that because they're in a triangle, all the interior angles add up to 180. So we can set up another equation, y plus 15 plus 110 equals 180. You can move these two numbers over this side. So that will get you y equals 55 degrees. Boom. Okay. Let's move on to some angle properties and shapes. So this one's a bit more higher level, these are for this is what you expect on a test. Okay, this is what you're going to be expected to do on a test, whether you're IB or D stream, but this is more likely to be an IB unit test. So this is a combination of both the shape properties and the angle properties. So you're asked to find x, y, and z. Okay, first step, you notice that these hatch marks, we draw the hatch marks. These hatch marks, these arrowheads, they indicate that this is a parallelogram because you have two opposite sides, two pairs of sides that are parallel. This one and this one, and this one and this one. Okay, so it's a parallelogram. And also we see, you guys can also spot a triangle there, right? Okay, so I just want you guys to notice that before we go into the solving part. Okay, we have two parallel lines, and we have this segment here. If you guys are familiar with it, we can say that this is a transversal. And this is a first parallel line, second parallel line. Okay, and it's cut by a transversal here. And angle X is right here, and angle 70 is here. So as you guys see, you guys are probably familiar with this pattern. You see the corresponding angles, and you see that F pattern, right? So X would be 70 degrees corresponding. Okay, you see here corresponding angles, F pattern, boom, boom, or like boom, boom. This has a similar diagram in shape like that. Okay, they're both, this one is above the first parallel line, and it is enclosed and it intersects with the transversal. This one, it's also above the parallel line and also hits the transversal, hence they're corresponding, right? Okay, you have Z equals 70 degrees, and here you want to find Y. So we have another smaller triangle inside. If you look carefully, you have a bigger triangle, a smaller triangle, and a parallelogram. So we have a smaller, in this smaller triangle, you guys probably remember from this rule here, all the interior angles in a triangle add up to 180. So we can say that 30 degrees plus 70 plus y equals 180. Move these two over here, so y equals 180 minus 70 minus 30, which is 80 degrees. Okay, good. So y equals 80. So our last step here is to find z. Okay, so we see that this angle, we can call that I'm gonna call it K. All right, so angle K, you can see it's opposite to angle Y, so angle K is going to be also 80, right? So 80 degrees. From here, our last step is to actually consider the parallelogram, right? Parallelogram rule, I said earlier, in a parallelogram square, remember it's a rectangle, opposite sides are congruent. So this side here, boom, they're opposite, right? So that would be 70 as well. Okay, so now you have another triangle. It's a lot of triangles. You have another triangle here, and you know that the interior angles of a triangle add up to 180. So you can say that 180, because you can say that 80 plus 70 plus z equals 180. You can solve for z by moving them over to the other side. So that will give you z equals 30 degrees. Boom. Okay. Last question. We have this diagram here, and we have two parallel lines. And you're asked to find x and y and z. So first thing you guys want to notice is that these two parallel lines form a what? A Z pattern, right? Good. They form a Z pattern. And that means that this angle be the same as this angle. As we go back to the Z rule, back here, alternating angles, right? Z and 77 are alternating, so Z equals 77. Next, we also see X and 52 are also lying on the same Z pattern. Hence, X also equals 52 degrees, right? Okay. Now, we want to find angle Y. How do we find it? So we know that, let's label in. So Z equals 77, and we have 52 here. And so in a triangle, we can use a 180 rule. So 77 plus 52 plus, let's call that angle K, plus K equals 180. So K would be 51 degrees. All right, and we see that to find Y, it's pretty obvious by now. Y and K lie on the same straight line, so they add up to 180. So Y plus 51 equals 180. Solve for Y, which will give you 129 degrees. Okay, so this wraps up our lesson of angle properties. Hope you guys learned a lot.